Okay, already you have written 4 points. This is number 5 point. According to this, the number of molecular orbitals, the number of molecular orbitals form the number of molecular orbitals form is equal to the number of combining atomic orbitals. I mean, when you combine two atomic orbital, you will get two molecular orbital. For example, 1s, when combined with another 1s, it will form, after overlapping, it will form two molecular orbitals like this. This is one molecular orbital, this is another molecular orbital. I mean, number of molecular orbitals will form is equal to the number of combining atomic orbitals. When you combine two atomic orbital, you will get two molecular orbital. Now, why it produce two molecular orbital you will get later, but you should know first time when two atomic orbitals combine, they produce two molecular orbitals. Now number 6 point, when two molecular orbitals combine, when two atomic orbitals combine, they form two molecular orbitals. They form two molecular orbitals called bonding molecular orbital, and another is called antibonding molecular orbital. So when two atomic orbitals combine, they form two molecular orbitals. One is called bonding molecular orbital, and another is called antibonding molecular orbital. As I have given, when 1s combine, it will form two molecular orbital. One is called bonding, one is called antibonding molecular orbital. This is number 6. Now number 7, the bonding molecular orbitals have lower energy than their and greater stability than their corresponding antibonding molecular orbital. मतलब बॉन्डिंग ऑर्बिटल का एनर्जी कम होगा, एंटी का एनर्जी ज्यादा होगा. फॉर एग्जांपल, व्हेन 1s combine with 1s, it will form two molecular orbital like this. You will get two molecular orbital. One is called bonding, one is called antibonding. So this bonding have greater stability and it has lower energy as compared to its corresponding antibonding molecular orbital. I mean, when two atomic orbital combine, it will form two molecular orbital. One is called bonding and one is called antibonding. The bonding have lower energy, greater stability than its corresponding antibonding molecular orbital. Number 8, bonding molecular orbitals are represented by sigma, pi, delta, etc. This type of symbols are used to represent the bonding molecular orbital, and antibonding molecular orbital are represented by sigma star, pi star, this type of star, delta star, etc. Normally bonding molecular orbitals, they are represented by sigma, pi, delta, this type of symbol, and their anti-bonding molecular orbitals, they are always represented by star symbol. If your bonding molecular orbital is sigma, then its anti-bonding will be represented by sigma star. If your bonding is pi, then its corresponding anti will be represented by pi star. I mean, bonding represented by sigma, pi, delta, this type of symbol, and anti represented by using star symbol. This is according to number 7 point. Number 8 point. Number 9 point. The shape of molecular orbitals. The shape of molecular orbitals form. The shape of molecular orbitals form depending on the type of combining atomic orbitals. Already I have told you about this. So what type of shape of molecular orbital you will get, it depends on the combining atomic orbitals. When 1s combine with 1s, you will get one shape of molecular orbital. When 2p combine with another 2p, you may get another shape of molecular orbital. So depending on the nature of atomic orbital, you will get the shape of molecular orbitals. And the number 10 last point, the filling means when you fill up the electrons, the filling of molecular orbitals, when you fill up the electrons in molecular orbitals, the filling of molecular orbitals takes place according to the same rule as in atomic orbitals. I mean, when you fill up the electrons in atomic orbital, you have got some rule now, like Pauli exclusion principle, Abba principle, Hund's rule. That same rule also you have to apply here. As you know, according to Pauli exclusion principle, and in an orbital maximum 2 electrons should be present, and that's why you have entered 2 electrons maximum. Similarly, in molecular orbital also you have to enter maximum 2 electrons. And according to Abba principle, you have to enter the electron first time in that orbital which have the lowest energy. Similarly, you have to apply that rule here also. Those molecular orbital which have lowest energy, in that orbital you have to enter the electron first. After that you have to enter in higher energy cell. In case of equal energy orbital, first time you have to enter the electron single, then you have to do pairing according to Hund's rule. That rule also you have to apply in molecular orbital theory. So same rule you have to apply in molecular orbital also as you apply in atomic orbital. So molecular orbital filling system and atomic orbital filling system both are same. So in next class I will give you how the molecular orbitals will produce, why 2 atomic orbitals combine to form 2 molecular orbital, why one is called sigma, one is called bonding, one is called anti-bonding. So all these things you will get in the next class. Thank you.